remember when it's asking you if you had to know what are the possible rational zeros, that's where you use that rational zero theorem, the P over Q thing. You can look back at the back side of your formula sheet if you forgot that. Okay, but then pay attention because it wants to know which ones are not possible rational zeros. So I would still make your whole list, but then you got to find which of the things listed there is not in your P over Q list. So for making our list to find the possible rational zeros, I reminded you that this is where we do that P over Q thing, where P stands for the factors of the constant, right? So P could be 1 or 6, because 1 times 6 is 6, or 2 times 3. And then Q is 3, because it's, remember, the factors of the leading coefficient. So 1 times 3. So remember, you have to, when you're doing your P over Q list, you have to take each of these numbers. So we'll start with 1 divided by each of these numbers. 1 over 1 is just 1. Then you do 1 over 3. Then you have to take 2 over 1 and 2 over 3. Then you have to take 3 over 1 and 3 over 3, which 3 divided by 3 is 1. We already have that in our list. Then 6 divided by 1, which is just 6, and 6 over 3, but that's 2, and we already have that in our list. So now that we have the list, remember it said which is not a possible zero. So if you look, positive and negative 1/2 are not in the list that we just made. 2 over 3 is, so is 2, so is 6. So 1/2 is the only one that's not a possible rational zero. Okay, we're going to be getting into 2.7 today. Okay, so our first theorem from 2.7 that we're going to be learning is called the fundamental theorem of algebra. So I'm not going to stand here and read the fancy way that the book writes it to you. I'm just going to summarize it for you. Basically, it says an nth degree polynomial has exactly n solutions. So you need to write that down in your notes. What that would mean, let's do an example with numbers. If it were a third degree polynomial, it's going to have 3 solutions. So remember, normally solutions, another name is the x-intercepts. So a lot of times if it's degree 3, you're going to see it cross the x-axis 3 times, okay? If it's degree 5, you're probably going to see it cross the x-axis 5 times, okay? You do have to remember, though, that some of the solutions could be imaginary. So you might, if it were degree 5, you might not see all 5 places where it crosses the x-axis, but there's still going to be 5 solutions. That's why there's this little note here, okay? You need to make sure you include that in your notes too. So when we say that there's n solutions, that means that you have to count the imaginary solutions too, and the repeated solutions. I'll tell you what we mean by that in a second. All right, so let's just look at a couple of examples. Here's an example where this polynomial would be degree 3, because remember, when you're finding the degree, we learned this back on like the first day of chapter 2. You just look for the highest exponent. So if the highest exponent is 3, the degree is 3, which means it should have 3 solutions, which are all circled in the picture there for us. You can see that it crossed the x-axis at 3 places, okay? So sometimes it can have what we call sort of a double zero. So like, see how this would also be a degree 3 polynomial. I didn't give you the equation this time, but it looks like it only crosses the x-axis twice though. But this one will be like a double solution, a double zero. You'll see what I mean more when we do actual examples in a minute. But let me make up numbers for a minute. Let's pretend this crosses the x-axis at 1 and this is -3, for example. The factorization of this would then look like x plus 3 if -3 is the solution. And then it would be x minus 1 and x minus 1 again. That's what we kind of mean by a double zero, like it's going to have the same factor twice, okay, if that were to happen. So that's just an example. Think back to parabolas. Like, remember, those are degree 2 polynomials. Remember how it can just, like, it can cross the x-axis twice, but it can also just sit on the x-axis. But guess what? The factorization of this, see how it crosses the x-axis at 4? But the factorization would have to be x minus 4 times x minus 4 again. So like you could FOIL that out and it would end up looking like this, right? But that's why sometimes, again, you're going to have what we call a double zero if it's the same factor times itself. Okay, so just keep that in mind. So let's look at some examples where we just have to say, how many solutions does this polynomial have? We don't have to actually find the solutions, just tell how many they are. So if you look at this first polynomial, you're going to want to look and find the degree of it. So look for the highest exponent, and it's 3, right? So how many solutions is it going to have? 3, whatever the degree is, okay? Look at the next one. How many zeros does this function have? Again, look for the degree. That would be the highest exponent, and that's a 4. So how many zeros will it have? 4. It's going to have the same number of solutions as whatever the degree is, okay? Now, again, that may or may not mean that we can see it cross the x-axis 4 times. Like it could be like 1, 2, 3, 4, but you might not be able to see all 4 of them because some of them could be imaginary, but it's always going to have 4, okay? So this time it says find all the zeros of the polynomial function. Let's think about how many there would be first. So let's find the degree. If the degree is 3, then there's going to be 3 solutions. Okay, so let's start by thinking, what are the possible solutions? That's what we already learned how to do last week. Like we're going to make that P over Q list to help us find the possible rational solutions. So remember, P is the factors of the constant term. So 1 times 9 or 3 times 3. Q is the factors of the leading coefficient. That's just 1. So our possible zeros would be plus or minus P over Q, right? So 1 over 1, that's just 1. 3 over 1, that's just 3. And 9 over 1, that's just 9. So remember, what we would have to do to confirm, like, is 1 a solution or -1 or 3 or -3? Like, there's 6 options there. We have to do synthetic division, but remember, we don't want to do it 6 times. This is why we're going to type the polynomial into our calculator so we can narrow the list down from 6 things to less, hopefully, okay? So let's go to our y equals, clear out what is ever in there, and type in our equation. So x to the third plus 7x squared plus 15x and plus 9. And remember, Zoom 6 is a good starting place. It's going to give us a standard window from -10 to 10 on the x-axis and -10 to 10 on the y. What we care most about is where does it cross the x-axis, right? That's another word for zeros or solutions. So it looks like -1, 2, 3, and actually at -3, it looks like it might be what we call a double zero because of the way it's sitting on the x-axis. So it looks like -3. Let's just start there, okay? So remember what we do? -3, check, it is in my list, right? So it is a possibility. So we're going to check and see if we do synthetic division with -3. So let's lay out the coefficients. 1, 7, 15, and 9. We don't need any zeros because there's no terms missing, right? It goes from x to the third, second, first, and then the constant. So we'll go ahead and do synthetic division. Carry down your 1. -3 times 1 is -3, right? You guys go on and finish it. So hopefully you're getting pretty quick at this. Now we add straight down. 7 plus -3 is 4. Multiply again. -3 times 4 is -12. Add straight down again. Multiply. -3 times 3 is -9. And we get 0. So remember, guys, your factor is always going to look like this. So if the 0 that we just got was -3, remember how minus and a negative, remember how the factor is going to look like x plus 3, okay? We can't forget that, because if you fill in -3, -3 plus 3 is 0. What's left? Remember, you're going to look at the coefficient. These numbers are the coefficients. We started with the degree 3 polynomial, so this should now be degree 2. 1x squared plus 4x plus 3. Now that it's degree 2, let's leave this alone. We can try to take this and just factor it, right? Like, think to yourself, what can you FOIL out that would give you x squared plus 4x plus 3? Give you a minute to think about that. This one should be super quick because the only way to get 3 is 1 times 3. Like, the factorization is just going to be x plus 3 times x plus 1. If you can sit here and check and FOIL it out, you will get this back again. So that's the factorization, right? We should put f of x equals. So the solutions, remember, would be -3, since -3 plus 3 is 0, -3 again, and -1. So if you look back at your graph, that makes sense because we said -3 was probably going to be a double 0. We have the factor x plus 3 twice. That's why we call that a double 0, and then -1. So we know for sure we're done because we have 3 solutions, and we said in the beginning that there should be 3 solutions since it was a degree 3 polynomial, okay? So again, if you have a double solution, like the same thing twice, it counts as 2 different solutions, even though it looks like only one when you look at the graph, okay? Questions so far at all? All right, let's try a degree 5 polynomial, which means there's going to be 5 solutions. So this one is going to be a little bit more work, right? The last one only had 3 solutions. So we can start by thinking, what are the possible solutions? That's where we think about P over Q, right? So what is P? It could be 1 or 14 or 2 or 7, right? And Q is just 1 again. So that makes it a little easier, less possible things, right? So positive or -1 over 1, positive or -2 over 1, positive or -7 over 1, and positive or -14 over 1. Again, that's 8 possible places, though, that it might cross the x-axis, right? We don't want to do synthetic division 8 times till we figure out the right answer, right? We're going to look at our calculator to help us narrow down the list a little bit. So a long polynomial to type in this time. We got x to the 5th minus 4x to the 4th. Then it goes plus 4x to the 3rd plus 10x squared minus 13x and then minus 14. And there's nothing missing, right? Because it goes x to the 5th, 4th, 3rd, 2nd, 1st, and then the constant term. Let's go ahead and hit zoom 6 again. We'll start with a standard window. Remember, there's supposed to be 5 solutions because it's a degree 5 polynomial. We can only see 3 places where it crosses the x-axis. Technically 2, but at -1 here, that's going to be a double 0. You'll see, like, we can do synthetic division with -1 and then do it with -1 again because it's going to be a double 0. Then it looks like +2 might be another solution. So we'll start with -1. Remember, you have to confirm, yeah, it looks like -1, but we have to confirm it showing algebra. That means do synthetic division with -1. So we got lots of coefficients to lay out this time, right? 1x to the 5th, -4x to the 4th, 4x to the 3rd, 10x squared, -13x, and -14. So bring down the 1, and you guys go ahead and do that synthetic division. So -1 times 1 is -1. Add straight down, and you're going to get -5. Negative 1 times negative 5 is positive 5. Add straight down, you get 9. Negative 1 times 9 is negative 9. Add straight down, you get 1. Negative 1 times 1, add, and then one more time, you get positive 14, so it will equal 0. So remember, guys, I'm going to write it like this for a second. Every factor is going to have the form of this, but since negative 1 was the solution, remember it's like x plus 1 is what the factor looks like. What do we have left? You remember these are the coefficients of the polynomial. It should be degree 4 still, right? Because if we started with degree 5, if you divide by x plus 1, you're still going to have 1x to the 4th minus 5x to the 3rd plus 9x squared plus 1x minus 14. So remember when we looked at the graph how it looks like negative 1 is what we call a double zero because of the way it's also a maximum, like it sits on the x-axis. So we should be able to do another round of synthetic division with negative 1 again. So take your coefficients and lay them out again. 1, negative 5, 9, 1, and negative 14. Bring down that 1 and go ahead and do it again. Yes. Negative 1 times 1 is negative 1. Add straight down, we get negative 6 times negative 1 again. That's positive 6. Add straight down, you get 15 times negative 1 is negative 15. Add straight down, you get negative 14, but when you multiply it by negative 1, it's positive 14. So let's keep track what we have so far. X minus negative 1, right? That's going to be x plus 1. Then you got it again. Let's write what's left. It would still be a degree 3 polynomial, right? These are the coefficients. So we have 1x to the 3rd minus 6x squared plus 15x minus 14. If it were degree 2, we could just factor it to finish it. But we're going to have to do synthetic division one more time still. How do we know where? Well, it looks like it crosses the x-axis at 2. Let's double check if 2 was in our list originally. Yes, 2 was in our list, so it's a feasible choice. But we have to just do synthetic division with these coefficients of 1, negative 6, 15, and negative 14, and just see if we get 0 or not. So one more time, go ahead and do this synthetic division. So 2 times 1 is 2. Add straight down, you get negative 4. 2 times negative 4 is negative 8. Add straight down, you get 7. 2 times 7 is 14. So yes, we're going to get 0. So again, we had this factor twice because negative 1 was a double solution. When we're all done, we'll write that as x plus 1 squared, okay? Then we're going to have x minus 2. And then let's write what's left. 1x squared minus 4x plus 7. We've finally gotten that down to a degree 2 polynomial. So let's write what we have. 3 factors, right? And actually, guys, let's, you're going to try to think, is there something you can FOIL out to give you x squared minus 4x plus 7? But let's think back to our graph again. Remember how negative 1, and 2, like let's plot those zeros. Negative 1, that's a double 0, and 2. So look back at your calculator screen, like it's going to start down at negative infinity, and it's going to go up, then come down again, then go up again, right? So let's sketch out the graph real quick. So we have 3 solutions. Again, it only looks like 2 in the picture, but we have negative 1 and negative 1 again, and then positive 2. We can't see the other 2 solutions, but there's supposed to be 5 factors if there's the degree is 5. So if you can't see the other 2 places where it crosses the x-axis, that should be a hint to you that we're not going to be able to factor this because guess what? The other 2 solutions are going to be imaginary. So you can sit here and try to think like x times x would give me x squared. There's no, like negative 1 times negative 7 would equal 7, but it doesn't add to negative 4, right? So again, the other 2 solutions are going to be imaginary. So since we can't factor it, guess what? We have to use the quadratic formula. Remember that back from chapter 1, that when you can't solve something by factoring, you have to use the quadratic formula. That's on your formula sheet. If you forgot it, it's on your chapter 2 formula sheet. So let's set this up. The opposite of b would be -4 plus or minus the square root of b squared. Again, b is -4 minus 4 times a times c. A is 1 and c is 7, and it all gets divided by 2 times a is 1. So we'll simplify a little bit. The opposite of -4 is +4. Underneath this square root, -4 squared, guys, don't forget to put parentheses if you need your calculator for this, because -4 times -4 is +16. If you don't put the parentheses, you're going to get the wrong number. -4 times 1 times 7 is -28, and it's all going to get divided by 2 times 1 is 2. So again, guys, what's going to happen is underneath the square root, 16 minus 28, we're going to get a negative number. That's -12. That's why the solutions are going to be imaginary. Remember, you can't take the square root of a negative number. So we're going to go think about this off to the side for a second. Remember, what we normally do is write it as the square root of -1 times 12, because do you guys remember back from chapter 1? The square root of -1 is I. Remember that? That's like the definition of I. It stands for an imaginary number, because the square root of -1 is not real. It doesn't exist. So we define it as I. So normally we would just write I radical 12. But remember, 12, it doesn't come out whole. If it did, if that was like 16, that'd be nice, because that'd just be 4. You just write 4I. But you're going to have to simplify 12, remember. So you got to find out what perfect square goes into it. 4, right? Because remember, we separate that. Like the square root of 4 is just 2. So we're going to write that as square root of 4 is 2. I'm going to write the 2 first, then the I, because we always write the number part first, okay? So coming back over here, we're going to have 4 plus or minus. Instead of this, we're going to write what we just simplified it to be, 2I radical 3. So all of this work that I did over here, guys, that's back from chapter 1. So I hope you remember it. If you don't, you'll get the opportunity to practice another one in the next question. But I wanted to walk through the steps again just because I didn't know if you would remember it or not on your own if I just had let you do it by yourself. Next time I will let you do it by yourself now that I've reviewed, okay? So now at like the plus and minus sign separates two terms that both have to get divided by 2. So you have to do 4 divided by 2, that's just 2. But you have to do 2 divided by 2 also, which is 1. But we don't really need the 1. Like 1 times I is just I, right? So like the final 2 solutions are going to be 2 plus I radical 3, and then 2 minus I radical 3. So they're imaginary. That's why we can't see them on the graph. So those would be your solutions, along with, now guys, I'm going to show you how to write the factorization. Like this thing, you would just fill in here, like it would say 2 plus I radical 3. And then here it would say 2 minus I radical 3. So the final solutions would be the imaginary numbers we just found plus -1, remember, is the double 0, and then +2. So we'll just list them all out. -1, -1, 2, and then the 2 imaginary ones. There should be 5 total solutions, because remember, it was a degree 5 polynomial. Okay, again, we can only see 3 of them in the graph, but there has to be 5 altogether, so the last 2 were imaginary. Questions on that at all? Okay, so we're going to do one more, and I'll let you do more parts of this one on your own. But again, the only thing new we learned today, guys, is that if it's a degree 5 polynomial, there's going to be 5 solutions. Okay, we may or may not see all 5 of them in the graph because some of them may be imaginary, but there's always going to be 5 solutions if it's a 5th degree polynomial. What are the possible solutions? We can think back to what we learned last week to help us. If P is 6, then 1 times 6 or 2 times 3. And then it's nice because Q is just 1. So we would just have to do positive or negative 1 over 1, positive or negative 2 over 1, positive or negative 3 over 1, positive or negative 6 over 1. Again, that's really 8 possibilities, right? We can't sit here and do synthetic division 8 times to see which ones of those are correct. So remember, we want to go to our calculator and type it in to help us narrow it down. So we're going to have x to the 5th minus 2x to the 4th. There's no x to the 3rd term. It goes right to plus 8x squared. So keep in mind when we do synthetic division in a minute, you're going to have to put a 0 in there since there's no x to the 3rd term. Minus 13x plus 6. We'll hit zoom 6 again, or you can just hit the graph button. So it looks like negative 2 and positive 1 looks like a double 0. So negative 2 and 1, let's check our list and see if those were there. Yep, negative 2 is there and positive 1 is there. So those are both potential solutions. Let's try synthetic division with negative 2 to confirm that it's actually right, though. So lay out your coefficients. Again, you're going to have 1, negative 2, 0, because there's no x to the 3rd term, then 8x to the 2nd, negative 13, and 6. So you go ahead and do your synthetic division and see if you get 0. Quicker it's going to be. So negative 2 times 1 is negative 2. Add straight down and we get negative 4. Negative 2 times negative 4 is positive 8. Add straight down, we get 8. Negative 2 times 8 is negative 16. Add straight down, we get negative 8. Negative 2 times negative 8 is positive 16. Add straight down, we get 3. Negative 2 times 3 is negative 6. So, yep, we're going to get 0. So, again, guys, if this is a 0, remember, the factor is always going to look like this, but we're filling in negative 2. That's why, remember, it turns into x plus 2. What's left if we factored out x plus 2? Remember, these are the coefficients of it. And if it was a degree 5 polynomial, it's still going to be degree 4. So 1x to the 4th minus 4x to the 3rd plus 8x squared minus 8x plus 3. So if it's still degree 4, we got to do more synthetic division. Look back at your graph. Remember we said it looks like it crosses at 1, and actually that looks like a double 0. So guess what? We should be able to do synthetic division with 1 if we lay out these coefficients. But then after you do it, you should be able to do synthetic division with 1 again because it's a double 0. So I'll let you go ahead and do it 1. So 1 times 1 is 1. Add straight down, we get negative 3. 1 times negative 3 is negative 3. Add straight down, we get 5. 1 times 5 is 5. Add straight down, we get negative 3. Times 1 again is negative 3. So we do get 0. Again, let's keep track of this. X plus 2 is a factor. Then, again, we would write x minus and then 1. Now, I'm telling you, what's left is still going to be degree 3. Let's write, these are the coefficients, right? 1x to the 3rd minus 3x squared plus 5x minus 3. But x minus 1 should be a factor again, which means we should be able to do synthetic division with 1 again. How do I kind of know that? Because look at where the graphs it doesn't really cross the x-axis at negative 1, right? Because it goes down and touches it at negative 1, but instead of crossing, it goes back up. So that's, whenever that happens, you're probably going to have this factor of x minus 1 in there twice, which means 1 is going to kind of be a double solution, which I call a double 0. So if we do it again, 1 times 1 is 1. You're going to get negative 2 and you add straight down. 1 times negative 2 is negative 2. Add straight down, you get 3. 1 times 3 is 3. So, yep, we get 0 again. So our factors are going to be x plus 2, x minus 1, and x minus 1 again. So really, we should write that as x minus 1 squared. We'll do that when we finish, okay? And I forgot to do that on the last one, I think. So you really should write it as something squared if it's the same factor twice. Anyway, these are the coefficients of what's finally a degree 2 polynomial now, right? So we can try to factor that, but it's a big hint, guys, that we can only see where this crosses the x-axis twice, technically 3 times, because at 1 it's a double 0. But that means the last 2 solutions, because if we only see 3, but there's supposed to be 5, that means there's supposed to be 2 more answers. They're probably going to be imaginary. So if you sit here and try to factor this out, there's probably nothing that you're going to be able to do, because think about it. If you do like x times x, that's x squared, but we could try like -1 times -3, but that would add to -4, not -2. So like it's not going to work. There's no numbers you could put here. So that means it doesn't necessarily mean, what's up, Renato? No, because -3 times +1 would equal -3, not +3. So that, good question, but that's why you're not going to be able to come up with anything that will work, because they'd have to both be negative in order for this to be positive and this be negative. So there's nothing that will work. So again, guys, you have to be careful, because it doesn't necessarily mean the solutions are imaginary. They are going to be here, but it could just mean the solutions are gross numbers, like radical 2, like things that are irrational. So they're either going to be irrational or imaginary, but no matter what, we have to use the quadratic formula if you can't factor it, okay? So we didn't really have that happen very much last week. That's the new thing we're working on today. If you can't factor it, you have to use the quadratic formula to find those last 2 solutions. So we're going to do the opposite of b, and b is -2 plus or minus the square root of b. So -2 squared minus 4 times a times c. A is 1 and c is 3. And it's all going to get divided by 2 times a is 1. So I'm going to let you take it from there. So opposite of -2 becomes +2. Once again, guys, when you're doing this, it's going to turn positive. You better put parentheses around it in your calculator. If you don't, you're going to get -4, but -2 times -2 is +4. -4 times 1 times 3 is -12. So you end up doing 4 minus 12, which again is going to be -8. That's why the solutions are going to be imaginary. So let's go off to the side and think about the square root of -8. So first of all, we usually write it as -1 times 8, because that -1 is going to turn into an I. You can't take the square root of -1. It's imaginary. But we have to remember that also, like, 8 has a perfect square in it, 4, right? So remember, you take the square, we can separate this into 3 separate square roots. So it's like the square root of -1 times the square root of 4 times the square root of 2. This is square root of -1 is I, square root of 4 is just 2, so I'm going to write that as 2I, right? I just wrote the I after the 2, because normally that's how we write it. This 2 stays in the radical, because the square root of 2 is not nice, right? It's a gross decimal. Square root of 4, we took the square root of it because it's just 2. So now, again, we're going to rewrite that as 2 plus or minus, write the simplified version, 2I radical 2, and it all gets divided by 2. So we have to do 2 divided by 2, that's 1, plus or minus 2 divided by 2 again, 1I radical 2. We don't really need the 1 in there, like 1 times I is just I, right? So your last 2 solutions would be x equals 1 plus I radical 2 and x equals 1 minus I radical 2. And then, okay, if we want to write the factorization, this part is just a little bit tricky. Remember, it always is going to look like this to begin with. Think about it with real numbers because it's easier to understand. Remember, we write x minus, but then like because that was a -2, it turns into a plus. So just keep that in mind, okay? Like the format always looks like x minus something. So what do we put right here? We put what the answer was, like 1 plus I radical 2. You're going to need to add extra parentheses because that's oops, I forgot the I. It's two terms. Like the solution is a 1 and it's an I radical 2. And then you have to put 1 minus I radical 2. And then technically, guys, like the x minus 1 times x minus 1, we should just write that as x minus 1 squared. I don't think it's going to ask you for the factorization on Edulastic. I think it's just going to ask you for the answers, which remember would be -2, +1, and +1 again, plus the two imaginary ones that we just found, okay? So again, notice that there's 5 solutions though, because it was a degree 5 polynomial.